Hi and welcome back to Common Core Algebra II. Today's lesson is 4.8, Inverses of Exponential Functions. And thank you so much for joining me, because taking the time to write the notes down before you come to class is really helpful. So that way when we go over some of these questions in class, you can spend really time just watching and asking questions based on what we did. So exponential functions are of such importance to mathematics that their inverses, functions that reverse their action, are important themselves. So exercise 1. Shown here is the graph f of x equals 2 to the x, right, along with the table of values shown. So the first question says, is this function one-to-one? And explain your answer. So of course we know one-to-one is the horizontal line test. Number one, it's a function. We know that. We're told f of x. So we're sort of told here that it is already a function, but the question here is asking, is this function one-to-one? And the horizontal line test is what answers that question. So slide up a little bit, and I'm going to open this. And make sure when you're answering these questions, that's not supposed to happen. This is what I want. Smartboard just does not want to work so well today. Here we go. So yes, make sure when you're answering this, you're answering complete sentences. Yes, this function is one-to-one. For each x value, there is a unique y value. That's the definition of a one-to-one function. Graphically, if a horizontal line is drawn, the function crosses it at most one time. So just saying passing the horizontal line test really isn't enough. You have to explain a little bit about what the horizontal line test is. Okay? So, if you need to pause and write that down, feel free to. B says, based on your answer from part A, what must be true about the inverse of this function? Well, the inverse of a function that's one-to-one will also be a function. Hopefully you're going to remember that part. So, again, we're going to make sure the inverse of this function will also be a function because f of x is a one-to-one function. Make sure you're always explaining your thoughts. On the right, it says, notice that as always, the graphs of f of x and f inverse of x are symmetric around the line y equals x. So that's the line that's shown there in the middle. So when we get to the bottom, we start graphing this. It should be symmetric around that line, and you can always put it in to make sure that that's happening. So C says, oh, I need to leave this here. C says, create a table of values below for the inverse of 2 to the x and plot this graph on the axis given. So that just means we're going to flip at the x and the y's. So my x is 1 over 8 when my y is negative 3. My x is 1 over 4 when my y is negative 2, and so on. Okay, and then it says graph it. Oops, so let's go back up again, and let's graph it. So you can spend some time graphing this on your own if you want to. You do have the notes for this lesson, so you can actually graph these points, and it should look like something like I've just done up in the green. And as you can see, it is symmetric. It's kind of, if you fold it over on that y equals x line, it should fold over on each other. Now it says, what would be the first step to find an equation for the inverse algebraically? Well, I'm going to remind you, well, the one that we started with was y equals, instead of f of x, I'm going to say y, is equal to 2 to the x power. All right, so what's the first step? Oh, I remember, because if you have to find the inverse, that means you have to switch the x and the y. So my first step is going to be to switch the x and the y. So x equals 2 to the y, right? And then we have to solve for y. But how do we solve for y when y is the exponent? We don't know how to do that. So how can we define this? How can we define this function? Well, I think you can say, let's try you do it in words. So y is the function. We established that it is a function. Y is the function that is the exponent of 2 that gives you the answer of x. That's a little confusing, but there's really no other way to define this. So y is the function that is the exponent. So that's really important to say here. So y is the exponent. Okay? So we need another way to define y, because we can't write that down every single time we want to find the inverse of a function, an exponential function. So we're going to find a different way to write that down. So write this down, write what you need to, pause the video, and meet me on the next page. Okay, so here we go. Hopefully that wasn't too confusing to you, because now we're going to use a very scary word called logarithm. So we're going to define a logarithmic function. So the function y equals log base b of x is the name that we give to the inverse of y equals b to the x. For example, y equals log base 2 of x is the inverse of y equals 2 to the x. So this is what we just talked about on the previous page. So instead of writing that out, we could have just written out y equals log base 2 of x. All right, so if you look here, this is basically what we're talking about. Base b is right here. Raised to the exponent, we're saying y is the exponent, is equal to the answer that's x. Okay, so based on this, we see that the logarithm gives you its output, which is the exponent we must raise b to in order to produce its input, which is the x value. All right, so here's this little bit of a loop I like to use, because I like to start with base b, and I say b raised to the x is equal to y. All right, so that's something I don't have on your page, so I think you should maybe write that down. So that will work for anything. So in other words, if I just use my example, log base 2 of x is equal to y. Let's put the y over here. All right, what does that mean? It means, start with here, 2, start with the base, 2 raised to the y is equal to x. So that was the inverse that we were just discussing. Okay, so let's use that loop now to see if we can figure these out down here in exercise 2. So this is going to be 2 raised to some power. Now in this case we don't have a variable. 2 raised to some power is equal to 8. So of course we know that that some power has to be 2 times 2 is 4 times 2 is 8. So this is 2 to the third power, so this is equal to 3. So same thing here. 4 raised to what power is equal to 16? 4 raised to what power is equal to 16? This is going to equal 2, because 4 squared is 16. 5 raised to what power gives me 625? 5 raised to what power is 625? Well, 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So this is going to be equal to 4. 10 raised to what power is equal to 100,000? 10 to the what power is equal to 100,000? Well, remember, This is 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth. So this is going to equal 5. I think the loop makes it easier. It makes it even easier for me. So let's go down here. Now we're going to do 6 to the what power is equal to 1 over 36. Well, you know 6 squared gives me 36, but because it falls into the denominator, this has to be negative 2. 2 raised to the what power gives me 1 over 16. So 2 to the what power equals 1 over 16. By the way, I almost always rewrite it. I translate it. I tell you that all the time from mathematics. So I know it has to be negative because it falls into the denominator. 2 times 2 is 4 times 2 is 8 times 2 is 16. Negative 4. So this one I'm going to rewrite completely. I'm going to say 5 to the what power is equal to this. 5 to the what power is equal to 5 to the 1/2 power. Well, so this is going to equal a half. And this is going to be 3 raised to the what power is equal to 9 to the 1/5. I'm going to rewrite 3 as base 3 here, right? So this is 3 squared to the 1/5. So I know having the same base, this has to be the same. So the answer here is going to be, I'm sorry, right here, it's going to be 2 over 5. So I'm hoping you just watch that for a little while, and now you can take time to actually sit and write it down. So pause the video, write them down, and meet me at exercise 3. Exercise 3. If the function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would represent the y-intercept? Okay, well, we know, you could graph this, by the way. You can graph log functions here. So let's talk about what this means. Let's translate this. This whole thing here means, I'm going to remind you, y-intercept, ooh, that's a good idea. Let's start with that. That means x has to equal 0, right? So we have y is equal to log base 2 of 8, because 0 plus 8 is 8, right? Plus 9. So let's do this. What is log base 2 of 8? Use your loop. This means 2 to the what power equals 8. So we're talking about 2 times 2 is 4 times 2 is 8. So this is 3 plus 9 is equal to 12. So my answer is right here, number 1. Between which two consecutive integers must log base 340 lie? All right, well that means 3 to the what power is equal to 40. Well, I know that 3 to the, let's go over here. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. And 3 to the fourth is 81. So I know it has to fall between 3 to the third and 3 to the fourth. So I know it has to fall between 3 and 4. Right? You understand that? Because 40 would fall between these two right here. So they're saying which exponent would it lie between 3 and 4? When we talk about the square root, when we talk about the square root of, x, we don't put the 2 in there because we recognize that it's supposed to be a 2. Well, it's the same thing with this thing we call the common log. The common log says log base 10, and we use it so often that we actually do, if it just says log x, we're assuming that there's a base 10 there. Okay, so when you look down here at exercise 5, it says evaluate each of the following. Now you can use your calculator here, but what this is telling us, and we don't really even need to use the calculator, this is telling me 10 to what power is equal to 100, and the answer of course is 2. This is telling me 10 to what power is equal to 1 over 1,000. Well, this is 10 to the first, the second, the third, and because it's in the denominator, it's going to be -3. And this becomes 10 to the what power is equal to 10 to the 1/2. If we rewrite the square root as 10 to the 1/2, so we know here this has to equal 1/2. All right? So tomorrow in class, if there's anything here we need to go over, we will. And you'll have class time to be able to work on the classwork part of this lesson. I'm hoping that the loop helps a little bit, helps you understand it a little bit more. And until next time, as always, make good choices. And I'll see you tomorrow. Bye.